Hey guys, welcome to Chapter 6. In this week, we're going to do a review of the chapter you've completed on elasticity. So I want to cover some of the main points here, and in my personal opinion, I'm not the PowerPoint slide is kind of wordy. So what I'm going to be doing is kind of bouncing around a little bit between a Word document and an Excel document, and then back and forth here to this PowerPoint slide. But we are talking about, excuse me, sorry, the concept of elasticity, and very specifically, the main focus in Chapter 6 for us is going to be what we call the price elasticity of demand. So we'll be defining that. We'll be looking at how it works and what it all means, and looking at the relationship that firms have when they're considering price changes and how different price elasticities can affect total revenue for the firm. At the end of the chapter, there's also some discussion on some different types of elasticities, including cross-price elasticity of demand and the price elasticity of supply and things like that. But for the most part, we're going to be focused on this concept of price elasticity of demand. So when we talk about elasticity, I can replace the word elasticity for you with another word, which is responsiveness. And if you think about how an elastic band works, some of them are very, very stretchy, and some of them are not very stretchy at all. Like you have to pull very hard on them to get them to move at all. And so we could say that some rubber bands, some elastics are more elastic than others. Some of them are more stretchy than others, which means they'll respond more to the pressure that you're putting on them. And we use this same concept in economics to talk about the responsiveness that variable A has to a change in variable B. So there's all kinds of different elasticities. And when we talk about the price elasticity of demand, what we're very specifically saying is that we are looking at that responsiveness. How much does the market respond, or how elastic is it to any changes in the price? So we know that we know from the law of demand that as price increases, then quantity demand will decrease and so forth. But the question we ask when we talk about price elasticity of demand is how much is that change? So if I increase my price by say 10%, then how much is the market response? Do we see we know we see a reduction in quantity, but how much is it? 5% reduction in quantity, or is it a 10% reduction in quantity, or is it a 20% reduction in quantity? And that's going to make a difference for firms making their decisions. So here, it's all kind of worded out, but I would just say that we can say that the price elasticity of demand, I'll shorten it to that, is equal to the percent change in quantity demanded divided by the percent change in, yeah, there we go, percent change in price. So in all my scrawling there, I've just kind of written out the basic formula for elasticity, the way it's kind of worded right above it. So we can just think of it that way. So I'm going to kind of skip over the next few slides because I think they're a little too wordy, and I'm just going to kind of bring in an Excel sheet that I've sort of quickly made here. Here is our formula, our basic formula for elasticity. So we say that the percent change in quantity demanded divided by the percent change in price is going to be equal to the price elasticity of demand, which I've shortened here to PED. So our price elasticity of demand is going to measure this responsiveness, and I have created a little equation down here where I've said I have a percent change in price of, I'm going to do an increase of 10%, and let's say that this results in a decrease of 20% plus 10%, there we go. And if I divide this out, what I'm going to get is this answer here, right? So a 20% decrease in price divided by a 10% increase in, a 20% decrease in quantity demanded divided by a 10% increase in price, it gives me an answer of -2. And this answer is something that we call the elasticity coefficient. Not a very important word, it's just the technical word for the answer that we come up with. And you'll see that if I change, so I've got my 10% increase in price and I do some different changes. Let's do a 30% reduction in quantity demanded. Well, my elasticity coefficient has changed. It's now -3. Let's do a 10% decrease. Well, now it's -1, right? If I did a 1% decrease in quantity demanded, which would be very small, a very low reaction from the market, then the elasticity of demand goes all the way down to the elasticity coefficient goes to 0.1. I could even say there's no market response at all, and therefore the coefficient becomes 0. So we're getting these different numbers, and it seems to be that as the responsiveness of the market increases, I just keep going up to larger and larger responses, this number itself keeps growing as well. So this is giving us a range. We're able to see that strong responses from the market have this higher and higher value. Low responses from the market have a lower and lower value, and that value can go all the way down to 0. So if I had 0 response from the market, I raise my price by 10% or 20% or 50%, and the market does not respond at all with any change in quantity demanded, then this would be something that we would call perfectly inelastic, which means that there is no elasticity here whatsoever. I don't see any response from the market as a result of my change in the price. So this would be like a mathematical extreme, although we will sort of see this a bit later in the course in a certain situation. But let's think of examples of where the market response to a change in price might be very small or nothing at all, be perfectly inelastic. And we can think that there are certain things, such as drugs, whether those drugs are there to save your life or whether they're just on the black market and people are addicted to them and they don't really care about the price, they just want the drug. The quantity of those drugs being demanded is not going to be very dependent on the price itself. You could take the price of, we've seen this in the United States, insulin for diabetics goes way up in price, and yet people still have to buy their insulin because if they don't, they're going to die. So the quantity demanded just doesn't really, we don't really see much of a response there, right? If this response is equal, so I'm going to do my 10% increase in price, and I'll do a -10 decrease in the quantity demanded, then this elasticity coefficient becomes -1. And here I'm going to make a point that because this answer is always going to be negative, we just do what we call the absolute value. And here you see I've got these bars around this answer. That's a mathematical expression for absolute value, which just means, you know what, let's just drop this negative sign. Let's say that equals that times -1. There we go. So instead of seeing negative signs all the time, just because they're always going to be there in this answer, I'm just going to drop it, right? So I'm going to take the absolute value, so my value will be 1 and not -1. So a 10% increase in price, a 10% decrease in quantity divided by a 10% increase in price gives me my elasticity coefficient. Let's actually just move that right over there. And -1 is my answer, and I'm just going to take the absolute value. I get 1. This indicates that the market response in terms of a change in quantity is exactly the same as the increase in the price in terms of percentages. So as I increase the price by 5% or 10%, the market response is to decrease the quantity demanded by 5% or 10%, and it just matches exactly. And these things are what we call unit elastic. For no particular reason, I'm just going to put in insurance here. This is a good example, actually, of a unit elastic product. It just tends to be true that the market responds evenly to those changes in price. And then we have elastic all the way up to perfectly elastic. So if I did let's say I did a 0.000001% increase in the price, it rounds to 0. And see, the math is breaking, and that resulted in a 99% decrease in the quantity demanded. You can see that the math isn't even working here on my Excel sheet. It's just breaking, right? So anytime you divide by 0, you're going to get the math breaks, and we would just say that this number has gone up as far as infinity, right? Anything in between, let's go back to something more realistic, 5% and a 5% increase in price results in a 80% decrease in the quantity demanded. Huge market response. That gives us a value of like 16, which is quite high. So you can see that we go from 0 for these perfectly inelastic products all the way up to 1 for unit elastic, and then any number higher than 1, and the higher it is, the more elastic it is, all the way up to possibly infinity if there was some infinite response to from the marketplace. And all of these would be elastic, ranging up to perfectly elastic. Right? So if I was to kind of look at this on a supply and demand chart, let's just draw one here. So I got my axes, I've got my price, and I've got my quantity. So if I was to draw a perfectly elastic product, the demand curve, or sorry, perfectly inelastic, I'm going to put a PE here for perfectly inelastic. The demand curve is this vertical curve, right? It still would probably slope at some point, because remember that demand is the willingness and ability to pay, and at some point, if you keep increasing the price, then the ability is simply gone. I can make that insulin $8 billion a unit, but nobody will be able to afford it, so quantity demanded would shrink to 0. But in this range that we're looking at here, I could set a price of 0 or $200 or $400 or $600. And the quantity demanded is just not going to, it's not really not going to change depending on those price changes. So at $200, we'll still have X quantity demanded. At $400, it's going to be the same. And the reason is quite simple. People won't demand a lower quantity because they need the drug to survive. And they won't demand a higher quantity because there's no need for insulin unless you have diabetes and need it to survive. So this perfectly inelastic, my fault, demand curve is just this vertical curve. And then similarly, if I did a perfectly elastic demand curve, it would be a horizontal curve. And this is to say that the demand is at $4 or $400 for your firm. Say you can produce and sell any given amount you want, 1 unit, 2 units, 3 units, X units, 6 units, 7 units, whatever it might be. But if you raise that price even the slightest amount, then your quantity demanded would shrink to 0. And if you were to lower your price by any amount, then the quantity demanded would increase to basically infinity. And that number would be somewhere way over here off the chart. So this line then just becomes horizontal. Right? So here's the ranges. Perfectly elastic is horizontal. Perfectly inelastic is vertical. And you can imagine that the curves in between, as we're moving from one slope to another, we're starting to see relatively elastic or inelastic, right? As the curve slope becomes more steep, it's becoming more and more inelastic, right? And as the curve becomes more horizontal, then it's becoming more and more elastic. So we can see this on the supply and demand chart through the slopes of these curves, that we are ranging in a variety of market responses in terms of those changes in price. The more up and down that curve is, the stronger the market response is to the price overall, the change in price overall. Now, why is this true? Like, what is actually causing these differences in market responses? Well, 3 of these I would think are in the textbook, and one of them I've just kind of added because it's important as well. So one of the reasons elasticities are different is because of the availability of different substitutes. So certain things are luxuries, certain things are necessities, certain things we can replace easily, with different options, and others we can't. So when it comes to something like insulin, right, that life-saving drug, there are few or no substitutes, and that makes it very inelastic, right? places to live, rent and housing. You don't really have options other than perhaps living in your car, right, or living at a shelter or something like that. So some things we just can't substitute. Food, we have to have food. So food overall is going to be very inelastic. But many of the things that we buy are much more substitutable. So, for example, movie tickets, right? Um, I have lots of different options when it comes to movie tickets. I can buy the movie ticket, or I could stay at home and watch TV, or I could go for a nice walk in the park, or I could find all kinds of different ways to entertain myself. And therefore, movie tickets are going to have a stronger response in the marketplace to changes in price. So, kind of on the left, we have inelastic, and on the right, we have elastic. Right? The other thing we would think about is pricing. Um, Proportion of income is just to say how much is this good kind of costing me in the first place. So if a good is very cheap, then it's going to be, it's less of a consideration, right? This is going to be less elastic than a good that is more expensive. And that's simply because it just takes up more, there's more of an opportunity cost. Right? More elastic, there we go. So if I do a 20% change in price, it does make a difference on how expensive that good was in the first place. If I'm talking about a percent change in price on an expensive good like a car, so let's say a car is $50,000 and I increase the price by 20%. Well, I've just put $10,000 on that cost of that car. And there's going to be a very strong market response to that. People are going to be very sensitive to a 20% change in the price of a vehicle, right? But if I took that same 20% increase or decrease and I applied it to some cheap good like salt, which is $1, suddenly salt becomes $1.20, and that does not make us much more likely to buy the salt or not buy the salt, right? We know by the law of demand it will result in a reduction of quantity demanded, but not that much, right? You're at the grocery store, salt's 20% more expensive. You shrug your shoulders, you put the salt in your basket, and you keep going on your way. So cheaper goods are less elastic, and expensive goods are more elastic. The other thing that those are the two main reasons, but also we think about the time horizon. Less time means less elastic, and more time is more elastic. And what we have here is the consumer's ability to respond. So to explain this better, an example would be something like gasoline. If the price of gasoline tripled tomorrow, we would expect to see a strong response from the marketplace, but not right away. Over a longer period of time, people would have the ability to go out and find better, more fuel-efficient cars. They would look for other ways to get around, like public transport or cycling. People would start carpooling. There'd be all kinds of ways that people would reduce their use of gas due to this, incredible increase in price. But that's not as true in the short run. The fact is that if gas went up, if it tripled tomorrow, most of us would still fill our cars up this week. We would complain. We would be not very happy, but we wouldn't reduce the quantity that we're using to the same extent because we're dependent on that gasoline, and we don't really have those other options. So we need time to figure things out, right? So we'll complain, but we'll still fill our car up. So in the very near future, this price change means not as much of a response from the marketplace, but over time, as we explore our options, then the elasticity becomes greater, right? And then finally, the definition of the market. And I don't think this is in your textbook, but I'm going to go ahead and put it here. Depending on what we're talking about, the broader the category, the more inelastic it is. And what I mean is like broader category is less elastic, and a narrower category is more elastic. And we'll use an example here. So a broader category would be, like I said, food itself is going to be very inelastic, right? Why? Because we don't have any substitutes for food. We have to eat. And we've seen in Canada grocery prices over the last number of years have increased quite a bit. But that doesn't mean that we stopped eating, right? We still all get our 2,000 calories a day. We might make different choices of the types of food that we're buying, but overall, we still buy a certain quantity of food in order to keep ourselves fed. But that becomes different if we narrow the category and say, well, what about the market for fast food? Um, the market for fast food is going to be more sensitive to that change in price than the market for food overall. You can increase or decrease the price of fast food, and people will respond by buying more or less, because the substitute that they have now is grocery store food, which is in the bigger category. So the responsiveness increases. And then I could take it further and I could say, well, what if I just did the market for fast food burgers became more expensive? Well, that also is going to have a stronger response. People will buy more or less fast food burgers because they will switch to other types of fast food, such as subs and shawarma and things like that, which are here in the broader category. So fast food itself won't change as much as fast food burgers, right? And then we could say, well, let's narrow it down even further. Let's say it's McDonald's, specifically McDonald's fast food burgers. They've increased in price. We will see an even stronger market response because the market will switch to the different options that they have, like Wendy's and Burger King, which is contained in the higher level category here, right? So each time I kind of narrow my category down, I see a more and more elastic response from the marketplace because people have more substitutes than McDonald's, and they have more substitutes than just burgers, and they have more substitutes than just fast food. So my definition here of how I'm defining the market also has a bearing on what is more or less elastic. So these are kind of these determinants. These are like pressures on elasticity. What are my options? How much is this kind of costing me in the first place? How much time do I have to make my decisions? And like, what are we talking about exactly here, right? So our definition of the market. So if I come back here, I have my very my inelastic goods, or my perfectly inelastic goods. These will tend to be things that we need. They will tend to be things that are cheaper, and this will also tend to be broader categories like food overall, or housing overall, or transportation overall, because we don't have any substitutes for them. So especially things like sugar and bread and eggs, right? These are cheap goods that we can't really substitute. You know, I guess there's sweetener, but you know, how else do you replace bread unless you just don't eat it? What can you use instead of eggs, or what can you use instead of milk? And these things are all very inexpensive relatively in the first place. So changes in price, or percent increases and decreases in price, don't matter quite as much, and they're much more inelastic than changes in prices for insurance, right? And if we were to go over here into an elastic range, we could look at other different food types and say, okay, well, you know, soda is going to be more elastic. And in fact, even more than that would be Coke Zero, right? That is a very specific type of soda. So people may substitute Coke Zero for other sodas, and sodas overall, they may substitute for just, say, drinks, right? Different things that we can drink. So the elasticity is increasing. And other things up here are more elastic as well. Even cheaper goods, but unnecessary goods like Netflix, right? Is going to be more sensitive, right? Those movie tickets we talked about, books, airfare. We see airlines adjusting their pricing all the time, right? So it's helpful for the firm to know exactly how elastic is my product, because it tells me how responsive the market is going to be to that change in price. So I'm just going to flip to a different spreadsheet here, because there's another important reason we need to be aware of our sensitivity to changes in price. And that's because different elasticities have different total revenues for the firm. My firm's revenue, sorry, one sec. I just had to give myself better access. My firm's total revenue is going to depend on the elasticity of these price changes. So here I've got something that's inelastic, and here I've got something that's elastic. So I'm going to do a price change of 10% increase, and then on an inelastic good that results in a 5% decrease in quantity demanded. So therefore, I do the division. The coefficient is 0.5. It's inelastic, right? Here, I've made that market response stronger. It's the same 10% increase in price, but it's a 15% decrease in quantity demanded. So I see a price elasticity of demand of 1.5. Now, total revenue is going to be price times, quantity. Total revenue for anything, basic concept, I take the number of goods that I sell and then how much did I sell them for, and that gives me my total revenue, right? So if I have I'm just going to use 100 units and $1 as my starting point. My total revenue, if I sell 100 units for $1, is $100. Straightforward, right? So in both cases, for the inelastic and the elastic good, before I made the change, I had a total revenue of $100. Let's do a 5% decrease in quantity demanded and that 10% increase in price. So 5% decrease in quantity demanded takes our 100 units to 95 units. That's 5% less units, and the price has gone from $1 to $1.10. That's a 10% increase in price. So if I redo that calculation, I take 95 units and I multiply it by $1.10, then my total revenue is now 104.5, $104.50. If I do a 15% decrease in quantity, that takes me from 100 to 85 units. And I multiply 85 units by $1.10, and I get a total revenue of $93.50. Right? So depending on the response from the marketplace, in an inelastic response, where there was a lower change in quantity demanded, when I increased my price, my total revenue actually went up. It went from $100 to $104.50. And here, when I increased my price by that exact same amount, the market response meant that my total revenue actually went down. So depending on the elasticity of the good, we will see different changes in total revenue. And in fact, if I did a 0% response, if I went perfectly inelastic, then no change in quantity demanded, but to any change in price. And once again, if I increase the price by, let's say, 50%, it seems to be that the more I increase my price, the more my total revenue is going up. Let's do a 100% increase in price with no change in quantity demanded. So that would be $2. Total revenue just keeps going up. So maybe I'm a greedy drug company and I do a 5,000% increase in price. And this has happened. And then no change in quantity demanded. So 5,000% increase in price becomes $5,000. And look, my Excel sheet can't even show us the number anymore. Some huge amount of money, $500,000 in total revenue, right? So yeah, it makes a very big difference. If I did that same huge $5,000, 5,000% increase in price, and actually, I don't know that we can do that here. Let's just leave it like this. So let's just be more realistic. Our 10% increase in price resulted in a 15% reduction. Total revenue has gone down. Let's do a 25% reduction. That means 75 units. Total revenue has gone down even further. A 50% reduction means even less total revenue, right? So our total revenue is connected to the price elasticity. And here's just a quick chart that shows those changes. If price is decreasing, then depending on whether the good is inelastic or elastic, if I lower my price, my total revenue will go down on an inelastic good, but up on an elastic good. and vice versa, right? So if I increase my price, if the good is inelastic, the total revenue goes up. If the good is elastic, then the total revenue goes down, right? So pretty straightforward idea. The dividing line, of course, that at the point of unit elastic, we would see no change in total revenue. So that's the tipping point between down and up. So here's our slide. I've clicked ahead quite a bit. We've actually covered slides 1 through 20 here. And again, I just don't think the slides are particularly helpful in trying to talk through them in this case. So here's a price elastic, price inelastic, and then price going up or price going down. So if I'm price elasticity of demand is elastic, then I increase my price and total revenue goes down. The opposite for the inelastic range. Right. So this will become important a little bit later in some of the future chapters. Okay, and so here I'm actually going to pull out an older slide deck that I had made some time ago, and just kind of this here, right here is some of the same concepts that we were just looking at. So I have my range of elasticities, right? I have them defined down here. And now I'm also going to suggest that we have a problem if we are just going to be using the basic formula of elasticity. And that problem is that I have an issue with percent changes. And this is to say that because I'm not measuring in dollars or units, I'm measuring my price elasticity formula is based on percent changes, then I run into something of a problem. And that problem is basically if I take any number and I'm going to increase that number by 10%. So let's say that is equal to that times 10%. And then I decrease that number by 10%. What is 10% of 110? Well, it's 11. So I'm going to take 11 off of that, and I get 99, right? So my increase of 10% and then a decrease of 10% did not bring me back to my original value. It actually took me further. And this becomes an issue if we're calculating elasticity because it does make a difference whether we are increasing or decreasing the percent change in the price and by how much and when. If I decrease, a better way of looking at that maybe would be to say, so let's just take a demand curve here. So if I have a demand curve, and if I do a decrease of 50%, so let's start at 100, then I would be moving from here to here, right, along the quantity. And let's say I now want to go back to this position. Well, if I do another 100% increase, so this would now be 50, right? 50% decrease takes me from 100 to 50. Well, let's do a 50% increase on $50. Well, that would only take me back up to $75, right? So I can't calculate the elasticity of this range of the demand curve using the same formula both up and down. This formula of percent change in quantity demanded divided by percent change in price is going to fail me if I am trying to determine whether this portion of the curve is elastic or not, right? So we have a different method, a longer equation than the simple equation. And here it is here. This is something we call the midpoint method. Now this looks very imposing, but it's not really as bad as it seems. And do not worry, you're not going to have to memorize this. We will provide it for you on the test, and you can have this available for you. So the price elasticity of demand using this midpoint method says I'm going to find the average change, and this is going to give me that entire range. It's going to show me actually the elasticity at some point along the curve, and I can calculate in both directions whether that range is elastic or not. So it's still percent change quantity. You can see all the Q's are on the top, and percent change price, all the Q's are on the bottom. But I'm going to say, okay, what is the difference between those quantities? and then what is the average of those quantities, and that's what this second portion is here, and the difference in the price and the average of the price. And on both cases, I'm going to divide top and bottom, and therefore I will get some answer. I'm going to get an elasticity coefficient. So in a real example here, we will use this midpoint method, and here's some numbers. So I'm going to go between prices of $2 and $2.20, and that takes me between quantities demanded of 10 units and 8 units. And here's my midpoint method formula. It's as simple as entering the numbers into this formula, right? So I have quantity 2, and it doesn't matter which direction I go in. I can say that this is 1 and this is 2, or I could flip these around and I'll get the same answer. That's why the midpoint method works. So just choose your starting point and your ending point and then enter your quantities. So here, quantity 2, this will be quantity 2 and price 2. So here's quantity 2, quantity 1, quantity 2, quantity 1, and so on. Just enter in those numbers and then begin solving your equation. Right? So here's my Q2 minus Q1. Here's my Q2 plus Q1. Here's my P2 minus P1. Here's my P2 plus P1. And then I'm going to do some math with that. I solve this down. I get negative 2 divided by 18 divided by 2 over 0.2 divided by 4.2 divided by 2. Continue on. Let's solve within the brackets. We're using bed mass. Negative 2 divided by 9, 0.2 divided by 2.1. And then eventually I can solve this down to this number here. Right? And the value that I'm going to get is negative 2.333. So I am therefore going to drop my negative sign, and I get the midpoint method of the price elasticity of demand. Okay, so why would it be important to use this midpoint formula? Because there's another concept here as well, and it has to do with how the elasticity works on the demand curve. So you will remember up here, we talked about how different the slopes of different curves will have different elasticities. But there's something that we didn't talk about yet, is that actually each of these curves is going to have a range of elasticities as well. So yes, a narrow demand curve or a slightly sloped demand curve will be more elastic than a steeper demand curve. But it's also going to be true that if I take any demand curve, there's going to be a range of elasticities here. I'm going to have a portion of this curve which is elastic and a portion of the curve which is inelastic, and then there'll be some breaking point, some tipping point where it's unit elastic, right? And why is this true? Well, it's kind of back to that determinant. Let's kind of redo this on a bigger screen here. Let's keep moving down. Boop, boop. We'll get that out of the way. There we go. So I have my curve. It is going to be like so. And again, I'm going to have demand. I'm going to have an elastic range and an inelastic range and a tipping point. So remember our example of cars, right? And I said that up here I've got a $50,000 car, and I decrease the price by 20%. So I'm going to see, at the very first place, we weren't selling very many quantities of cars at this very high price. But if I drop the price by 20%, that's going to result in a pretty strong response from the market. I'm going to sell a much higher percentage of cars than I did before, right? That is not going to continue to be true forever. If I drop the price of a car by $10,000, then I'm going to see a strong market response, and the car would now be, say, $40,000, right? If I drop that price again by another 20%, the dollar value will be less, but it will now be like $32,000, right? And if I drop it another 20%, have to do math in my head here, to 2,000, 4,000, 6,000. We're somewhere down here in the range of like 25 or 26,000, right? And if I keep doing this, eventually it's going to get ridiculously low, right? So I'm going to be at some point down here at the bottom end of the demand curve where we would be nowhere near the equilibrium price. And let's say cars in this range are $5,000, right? Well, for the most part, everybody is already buying a vehicle for $5,000. That's a fantastic deal. The market is responding. If I drop that price from 5,000 to 4,000, um, we won't see much of a percent change here in terms of quantity demanded, right? There will be people who couldn't afford 5,000, but they can afford four, and so now they buy the car. But it's nowhere near as strong as this response way up here at the top end of the curve. And remember, our second determinant of elasticity, the proportion of income matters. At very high prices, we have more elasticity than very low prices. So there's a range here. There's a range on this demand curve where the price is inelastic, right? Where the market response is not as strong as the range up here. Look at that. It made a little arrow for me. And I could even draw kind of a total revenue graph. And I could say that, do that again. There we go. I could say that if I drew a graph, a demand curve, and I recognize that here's going to be my breaking point, and this will all be elastic, and this will all be inelastic, then if I was to look at total revenue below it, so total revenue and quantity, as I increase the quantities, you can see the price is going down. But also because of that relationship between price and total revenue, as I'm decreasing my price in an elastic range, my total revenue is going up and up and up, right? And then there's this tipping point, wouldn't let me do the curve, where it becomes equal. And then on the inelastic range here, my total revenue is going down and down and down and down, right? So, and there's going to be that connection, that dividing line. Total revenue increases as I lower my price, and then total revenue starts decreasing as I lower my price. And of course, a firm is always going to want to maximize its total revenue, right? We're not going to think about costs yet. That'll come into place later, but a firm wants to get the most money it possibly can. So a firm is going to be kind of aiming for this point of unit elasticity. And if its price is too high, it may want to lower the price in order to earn more money, right? If its price is too low, it may want to raise the price to earn more money. How do I determine if the price is elastic on the curve? Well, I can't use that simple formula because I'm looking at a range, so therefore I need to use that midpoint method. So if I'm wanting to find out the elasticity of some range of the curve, say between here and here, right, I have to use the midpoint method, and call it MPM. So the midpoint method will give me the elasticity along this range, and a firm will be able to understand whether it should be increasing or decreasing the price in order to increase its revenue, depending on what the price already is. So those are the key concepts from Chapter 6, and Chapter 6 also does talk about other types of elasticity. Oop, I kind of kicked over a slide there. And I've just got these kind of outlined here. There's three other ones that we would talk about, but not in anywhere near as depth. The cross-price elasticity of, let's actually put that, of demand, the income elasticity of demand, and the price elasticity of supply. So these are just other types of elasticity. What we're saying is that there's an elasticity of demand, but it's not just the price, it's about the price of something else. Or the elasticity of demand, but instead of responding to price changes, it's responding to changes in consumer income. The elasticity of supply, the price elasticity of supply. How does the supply curve respond to those changes in price? And if we kind of move through these one by one, we could say, so we have the cross price elasticity of demand. And what I'm looking at here is kind of that same basic formula, but I'm actually talking about two different goods. So if I look at the change in price for Pepsi, what will the market response be for Coca-Cola, right? And just the price elasticity of demand, I'd be looking at change in price for Pepsi, percent change in quantity for Pepsi. Now I'm going to say change in price for Pepsi, percent change quantity in Coca-Cola. So there we go. So Pepsi has decreased its price, and we know because those are substitutes that means people will buy less Coke and more Pepsi. So I increase the price of Pepsi, and that decreases the quantity demanded for Coca-Cola, and I get a elasticity coefficient. And I can tell that these goods are substitutes because as both the numerator and the denominator are negative, right? The change in the price of Pepsi resulted in a negative quantity demanded in Coca-Cola. If these were complements, for example, like tennis balls and tennis rackets, a decrease in the price of tennis rackets would result in an increase in the price of tennis balls, and therefore my answer would already be would be negative versus the positive answer we got for the substitutes. So interesting. So a substitute will give me a cross price. A substitute will give me a cross price elasticity that is positive, and a complement will give me a cross price elasticity that is negative. So my range would look a little bit different. Instead of 0 to infinity, I would actually have 0 to infinity in both directions, depending on whether they are complements or substitutes. Right? So we can look at the relationship between goods, that connection between price changes and demand changes. Income elasticity of demand, the same kind of idea, depending again on whether we're talking about inferior or normal goods. Instead of looking at a price change in the good, what about dividing by a price change in the consumer income, percent change in consumer income? So I'm going to see an increase or decrease in quantity demanded, and that will be based on some percent change in income instead of percent change in price. And if it's if it's an inferior good, then we know that as income increases, the quantity demanded for that good will increase. If it's just a normal good, the as income increases, quantity demand would decrease. I was thinking about getting a pay cut. If it's a normal good, the increase in income will result in a positive increase in percent change in quantity demanded, right? So if my end result, if I get this coefficient of the income elasticity of demand is negative, then that tells me that I'm working with an inferior good. Why? Because a positive change in income resulted in a negative change in quantity demanded, right? Positive value is normal good, and therefore, once again, I have the line that goes in both directions, right? The range of outcomes could be infinitely negative, infinitely positive, or zero, which would represent no real response. So, and again, back to remember when we talked about inferior goods, these are things that you buy less of when your income goes up, like bus tickets and ramen noodles and things like that. Normal goods, the range will change. We have very little response. You don't buy more hydro, more electricity, or heating for your home when you make more money. It just kind of stays about the same. And so these necessities, you don't buy more milk. You just buy the same amount of milk, but you will buy more things like vacations and restaurant meals, and they'll have a stronger response to that change in income. And then finally, there's the price elasticity of supply, and again, percent change in quantity supplied divided by the percent change in price. Here we are once again going to be looking at a single scale, 0 to infinity. Why? Because that answer always has to be positive anyway, because any percent change increase in the price is going to result in a percent change increase in the quantity supplied. Both of these, both the numerator and the denominator, are always going to be positive, right? So this, you don't even have, you can take the absolute value, but it's already a positive. So there we have it. We're using the same scale. And we just think that, there might be differences in our ability to supply, which could result in different elasticities. So if I have concert tickets, my stadium will only hold 5,000 concert goers. So regardless of the price that I can get, if I can get $100 a ticket, that's great. I'm going to offer 5,000 tickets, right? If I can get $1,000 a ticket, that's great. I'm going to offer 5,000 tickets. If I can get $10,000 a ticket, that's great. I'm going to offer 5,000 tickets. There's no real change in that supply, in that quantity supplied, due to the change in price, right? So my ability to produce, I can't, in the short run make more seats. In the long run, yeah, I could build a bigger concert hall, but right now I'm limited. So the elasticity will be quite low for something like the number of seats available for a concert. Um, we have inelastic supply. The firms simply can't respond quickly enough to changes in price. So the price of apples goes up by 100%. The farmers will want to supply more quantities of apples, but you can't grow an apple tree very quickly. So they need more time to respond. Yes, maybe we can produce more from inventory, things like that. You need more time, right? So it's we go from 0 to an inelastic response where 0 0.1, 0.2, how quickly can we respond? And then we get into the elastic range where firms can easily respond, right? We have a factory, it produces goods, we can start offering overtime, we can ramp up the materials that we're bringing in. And for things like clothes or toys or a lot of consumer goods, then we can see a strong response from firms due to changes in price very quickly. So if the price of a widget goes from from $100 to $200, firms are going to immediately start producing a much higher quantity than they were before, and you'll see a much stronger response, a much more elastic response. So again, these are just the key points to be aware of, especially for testing. I don't want you to spend a lot of time on these three things because they're not that relevant for what we're going to be talking about in the rest of the course. But be aware of just how these are calculated, like what the differences in what we're measuring by. I'll tell you to be aware of the difference between complements and substitutes, and whether you get a positive or negative number on those. Uh, Inferior goods and normal goods, whether you get a positive or negative number on those, and just that the reasoning for why the price elasticity of supply changes the way it does. So I think those are all the key points that we need to know. Will be available, of course, for the drop-in, available by email if you want to discuss it more. Come and see me. I'm happy to help. But I hope that gives you a pretty good review of those concepts. Thanks, everybody. We'll see you on the next chapter. Take care.